Hey everybody, I was thinking about it and I'm just going to do all the lectures for the week. And on Tuesday and Thursday we'll talk about things that maybe were confusing. So I'm going to do basically 5 lectures this weekend, and I'm going to try and make it shorter than that last one because I felt like it was really long. And I probably bored you to death. So anyway, now we're going to talk about exponential functions, differentiation, and integration. I'm going to split this up into 2 parts to make it more digestible. So by the end of the week, we will cover the whole unit. 5.5 is the end of our unit right now, according to Robert's schedule, I think. I think it's his, but I'm going to say it is because it checks out. So let's begin. So we talked a lot about logarithmic functions, where we talk about ln of x, okay? It's basically, now we're going to talk about what the derivative of log of x is. No, not the derivative, excuse me, the inverse, okay? The inverse of log of x. The inverse of log of x is e to the x, okay? So if we define f as log of x, f inverse of x is equal to e to the x, where e log n of x is equal to x. Obviously, kind of going with last week's lecture. So this is probably the most important association that you'll make in this class as far as continuing in calculus. E to the log of x, or the log n, natural log of x, will be x. They like using that trick a lot in calculus too, so keep that in mind, okay? So that's the first thing we're going to talk about. Yeah, so let's begin. First example, solving exponential equations. So basically, this section kind of goes over integration and differentiation with this kind of like dual thing. So we start with the equation 7 is equal to e to the x plus 1. We want to find what the value of x is. So the way that we do that, I don't know how much you guys have been exposed to this, but I'm going to try and take it a little slower in this problem and move a little faster later on. So to get rid of e of x, we have to do a log function. So we'll take the log of both sides here, okay? So log n of 7 is equal to log of e to the x plus 1, okay? Oh, it's x, I'm sorry. So it's not x plus 1 or e to the x plus 1, it's e to the x plus 1 all in parentheses. My apologies for goofing that up a little bit. Okay, so that kind of makes it a little simpler. So since it's e to the x plus 1, e and log n cancel. So what we have is log n of 7 is equal to x plus 1. Log n of 7 minus 1 equals x. Fairly straightforward. And you just evaluate for the log and subtract the 1 and you have an answer. Apparently it's 0.946 or something. Yeah, so that's straightforward. So they're inverse of each other, and it makes computation not too bad, knowing that property. So here we have example 2, solving a logarithmic equation. Basically the opposite. We're going to go log of 2x minus 3 equals 5. Is that right? Yeah. So if we raise this to the e, or like e to the log of x, 2x minus 3 in this case, we can cancel it out. So let's raise both sides. E to the log of 2x minus 3 equals 5. Or sorry, excuse me, e to the 5th where e is actually like, it's a number. E is kind of like pi, but it's not pi, obviously. So that's something to keep in mind. I forget what the exact number is. I think it's like 2 point something, but it's kind of unimportant. You don't evaluate it often. But it's useful in the case of evaluating it. Most calculators will have an e that you can evaluate, e to the x, and be done. Okay, so sorry for being winded about that. But. Okay, so here we have this. If we break this down, now we have 2x minus 3. This is because these two cancel, not too bad, equals e to the fifth. So we have 2x equals e to the fifth plus 3. X equals e to the fifth plus 3 over 2, done, okay? I guess that answer is 75.707, okay? So, that's pretty straightforward as well. Just kind of going with what we had before, but now we know the inverse of log. So, now we have, we're going to talk about the derivatives of an exponential function. And then next lecture, I'm going to talk about the integral of an exponential function. So, theorem 5.11 on page 354 states that the derivative of g of x, or derivative, sorry, of e of x is equal to, simply enough, e of x. Isn't that nice? So, anytime you take a derivative of e of x, it equals e of x. Now, that also extends to anything in that logarithm. So e of u is equal to e of u. Now, we know from the power, something to keep in mind is the power rule, okay? And what they say is du by dx. That's where it gets important, okay? That's the power rule I was about to mention, okay? E of u du by dx means that you still have to take the derivative of the power. So if we have something like e to the 2x, it's a fairly basic one, du by dx is 2, right? That's the derivative of 2x. So we get 2 e to the 2x, and we're done, okay? So it's a really nice, simple rule. It gets crappy when you do differentiation by parts, which I don't think we cover in Calculus 1, but it's something to keep in mind later on. This rule is extremely useful for that because it actually makes things really simple when you do really complicated integrations and derivations, okay? So, really basic here. So let's just do a couple examples, and I think we'll be done for this lecture. It'll be a short one, which is nice. So let's just do a couple, or 1, 2, maybe? I haven't decided yet. We'll do one. I don't exactly know how crazy we need to get. We'll start with example 3a. Yeah, we'll do that one. And then we'll do b. Okay, d by dx of e to the 2x minus 1. Okay, so that's exactly what I just showed you. We know du by dx is going to be 2 because the 1 doesn't matter. We get 2 e to the 2x minus 1, and that's done. Wow, that was easy, right? Okay, so that's, just remember du by dx is always there if we actually have a u to deal with. Here we don't, but here we did. This is u, this is du by dx, and u stays, okay? Cake. Continuing on, we have a little bit more complicated one, e to the minus 3 over x. Yes, indeed. Okay, so what is our derivative? Well, we know it's x to the minus 1, so we subtract, and we get, well, let me write it out. U equals minus 3 over x. So that's useful when we have more complicated stuff. Du is going to be equal to, well, we have a minus 1 times minus 3 over x squared. So we get a 3 over x squared term there. And so that leaves us with 3 over x squared e to the minus 3 over x. And that is the answer we get in the book. Great. So that's the basics. Not too hard. Example 5 goes over a little bit more complicated one, but it's really not that bad either. It's the same thing. The steps are it's straightforward. I feel like this lecture was super short. I'm gonna finish this one because it's not that bad. Okay. No, I'm not. Okay, so that's it. That's it for now. This will be your lecture for Tuesday. Okay.